Okay, hello everyone. Let's go ahead and take a look at angles in space. Now that we have an idea of how we can generate the equation of a plane, we can now go ahead and talk about how a plane interacts with other three-dimensional objects and the angles that are created between them. So for example, if we have a line in a plane, how do we go ahead and determine the angle in which the line and the plane intersect? Now, the thing that we have to remember with regards to the plane is what vector are we going to use in terms of trying to determine its direction. And hopefully what you've been able to determine is that if we use the normal vector, then the normal vector will help us in many different ways. And one of the ways is, of course, helping us to determine the angles. So we're going to go ahead and focus on the normal vector of the plane. And then we're also going to head and take a look at the directional vector of line, of course, because that's establishing the line's direction. Now, of course, when we wanted to go ahead and determine the angle between two vectors, we always use the scalar product. And so we're going to do exactly the same thing here, where n is going to be the normal vector of the plane, and d is going to be the directional vector of the line. And so notice if we use the scalar product, we come out with this. And then if we go ahead and divide by the magnitude of n times by the magnitude of d, we come out with this. Now, theta is actually going to be the angle between the normal vector and the directional vector, which is not the same as the angle which the line makes with the plane. And so what we have to do is we just have to use some geometry here, and notice that I have two normals drawn. And if I go ahead and draw the two normals, then basically the directional vector acts very similarly to a transversal. And being that these are parallel to each other, the two normals are parallel to each other, we know that this angle theta, which is actually going to be calculated by the scalar product, is exactly the same as this angle alpha there, this angle theta there. But what we're really trying to find is the angle alpha. So what that means then is that I need to go ahead and change this from the cosine of theta, because we don't want theta, we want alpha, to 90 degrees minus alpha, because of course we're establishing a right triangle there. And we know for a fact that the cosine of 90 degrees minus alpha is the same thing as the sine of alpha. So now if we go ahead and take the inverse sine of both sides, then we basically got what we need, so long as we make sure that n dot d is going to be a positive value, because we know that the sine needs to be an acute angle. Okay, let's go ahead and take a look at the angle between two planes. Now, the angle between two planes is a little bit different because of the fact that we're going to be using the normals of the two planes. But again, we're going to be consistent in the sense that we're still going to try to find the scale. We're still going to use the scalar product to find the angle. So notice that we're going to go ahead and call the normal sub 1, the normal sub 2. If we dot those two together, we come out with this. And then if we go ahead and divide, we come out with exactly this particular expression here. Take the inverse cosine of both sides. And then we want to go ahead and ensure as well that the value of the angle is going to be an acute angle, and therefore positive, and therefore we let theta be between 0 and 90 degrees. And in order to ensure that happens, we make sure that there's the absolute value sign of the scalar product of the two normal vectors. Okay, so basically now that we have the vector form of the plane, which gives us the normal vector to the plane, we can now go ahead and use a scalar product to go ahead and determine the angle between a line and the plane, as well as the angle that is created by the two planes which intersect. Okay, so we'll go ahead and take a look to see if anybody has any questions about these types of questions later in class, the next time that we meet. Okay, so we'll see you later. Bye-bye.